must be longer than.
And wider.
I will show you. Because of technological operation, you have to do. Now, next step. Take any of the original gaskets you were using. Put it like that. Make mark. Marker. Have two marks where it is sent. Now next step is punch the holes. Understand those holes are same size. How to punch? You can use any technique you want. You can drill, but we are using puncher. So I'm putting puncher there to see that mark through the hole. Right in the center of the hole. One hole. Second hole. Almost same position. Then why I'm making longer? Because if you make a short, it's hard to make to cut. You must have a area of support for punching. If you make too small, then it's impossible to punch. You will deform gasket that metal and without and making hole will be you will be not able to make holes. So then usually you have to try to avoid the narrow edges. In your particular experiment, you don't have to do very precise shape of the gasket because you have lots of space there. But there is no limit on the length of the
So the shape is not necessarily should be rectangular.
Only the only one you have limitation that you will to make them short enough to don't hit pins. You have those pins. So if you will make too long, you will hit pin. That's it. Next step is fixing. I will check if it's possible everything, but I hope it's possible. Using screws. Screw technology is better than technology of the clay because clay can fall, can get dry. It's not very comfortable to work with. But with screws, you can always fix, remove as many times as you want. You might make like arc. It's not a big problem.
It can be
It
arc.
can be arc. It no matter. It's better to make arc than you pressurize it to diamond. That's it. So all the fixing. Next step is again making mark somewhere. If you're working like that, you make mark here. You mark your gasket. What was the position? Okay. Close the Anvil. So. So gasket is sitting right between diamonds. There is space. Next step is your screws. You must have a you also have left-handed and right-handed screws. Here, left-handed are marked by as red.
These are different from.
Yes, they are different and they are very stiff in my opinion. So I'm making one by one at the beginning because I don't know how stiff it will be that spring.
One by one.
One by one.
One this side, one.
Opposite side, yes. And I will make, I don't know how many I need to do, but I will make
You are going to make it one by one because you think it's.
they are very stiff. They much thicker. Those screws, those washers. So I don't know how strong they are. So I don't want to kill your cell right at the first experiment. So and I made. Second pair, 5 pair here. Let's see. I don't know what was the original idea, so how many it's supposed to be.
How important this spring?
Those springs are important. Without those springs, the pressure will go fast, very go up very fast. And you will be not able to make a equal pressure distribution on those force distribution on all sides. Because little turn make
Lots of pressure.
lots of movement. Because step of the screw is something like 1 millimeter. And thickness of your gasket is something like few micron. So the small change will make lots of movement. Those springs are for to reduce that. It works as like for amortization.
Now for beginning, how many spring did you put here?
5. I am not sure how many.
What happens if instead of like 1 by 1 you put 2 by 2, it goes faster?
It will go faster, yes. And since I don't have experience with those particular spring, and I didn't work too much with this cell, so I haven't worked with this cell, so I and again there is lots of parameters you really have to learn, because that cell has almost more than half millimeter anvil. I think that on one hand you have to apply lots of force to it. On the other, I don't want to kill that cell right over here. It's not correct. Other side. 4.
Here we don't have any mark for left-handed.
And then we have to learn which are left-handed, which are right-handed. For doing simple experiment. Take a left-handed screw. Here is left-handed screw. Try to put left-handed. That's it. Those are left-handed.
And is there any difference if we try from this side or
No,
the other side?
that's just more convenient. Will put more springs there. I will try to go with it was 320, yes, the thickness 330.
325.
330. It's what it's other. It's not your original.
The other, yes, it's 330.
So again, we must. I believe that in such diameter of the cullet, the correct size of the thickness of the gasket must be something like 100 micron.
Because this one is twice bigger than the other one. 100 micron.
So I'm making half turn here.
Can I ask how did you guess the right size for the cullet?
Yes, that's a very good question.
Just guessing.
Okay.
Experience.
Okay.
But it's related to the size of the cullet. You ask about the thickness of the.
Yeah, thickness.
What happen if, for example, we made it the thickness, if the thickness is more than 100 or less than 100, what will happen? For example, in this case, you said 100 micrometer should be good enough. But what about if, for example, we made it 50 micrometer? What will happen?
It will be. It's very rare situation. Then you will go to very thin. It's hard to make thin. You might break diamonds, first of all. So you must avoid making it very thin.
And even it's difficult to
It's difficult
reach to that.
physically because you increasing the pressure inside is increasing because the force you have to do it's more and more higher. So it means I don't believe you can even make like 50 micron in this. I hope we will make 100 micron here. I hope we will make 100 micron in this cullet because it's difficult. Again.
What about if we make it, for example, 200 micron? What will happen?
It's too because problem is if you make too thick. The mechanics you must read those paper about gasket theory of gasket. Mechanics is like that you have your gasket. It's supported here. If here you are creating very high pressure, that pressure works all direction. if the thickness of the gasket is too high, that area is becoming too high here, and your material will just push out the gasket. So the problem if your gasket is too thick, it will not hold the pressure. That's it.
This figure is from
From
this
the
side.
From the side.
This is from like this.
We are looking on the here on diamond, from the side of the.
So if while doing the experiment you see like your chambers,
Your chamber is expanding.
it
For
means
example,
it was too thick.
it was too thick.
Okay, thank you.
But it's again, those parameters are there. There is no single recipe for it because it depends on the size of your diamond, on hardness of your material of gasket, what material you are putting in. For example, if you have very compressible material like gases, it rather will collapse. If you have not compressible material, it will expand. So there is no single recipe. So you have to practice. But you see, for example, you are making gasket and it expands very much. So it means it's in your particular case it expands too much. You must start to make thinner. Try to make thinner again.
If it shrink, it means
Shrink, it mostly means that your materials either very compressible.
your material. You mean the sample?
Sample is
Uh-huh.
very compressible, or your material is not compactable. So it's not enough material in initial moment.
So the shrink means it nothing to do with the
It's
gasket.
It's also to do with gasket. For example, if you have two very thick material here, thick gasket and little of material, then gasket prefer to go that way instead of expand or remain same shape. So if you will go to thinner thickness, your ratio between this and this will be different. Then even if you have not compacted material, it will not collapse.
And one thing about how do you observe during the experiment? How can you see, for example, if it is shrinking or
Our system allows it.
your system allows it? But
Your
what
system,
about
you
if we don't have it?
Microscope.
I should bring it and observe it during experiments. So
I would recommend to you to do it. It's again it's
because
typically I believe you will do like that. You will increase the pressure and then cook. So it means there is no big problem. You're increasing pressure, put under microscope to check if there is still your sample there, and then cook whatever method you want.
So it's very important to observe it, because otherwise, for example, we will do the experiment and we cannot get the result and we don't know what is the problem.
The problem is that you will not have enough material, or your sample will collapse, cover your ruby, for example, because your material is not transparent for ruby, for example. So it means you don't want to have such situation. But if it's something like happened, don't worry too much. Take a next gasket and go ahead with next gasket. Such way I told you, prepare lots of gaskets. Put more material. Sometimes you see something like that, okay, collapse, but still it's fine. You see ruby, you see your material, it collapsed, but whatever. You see the rising of the pressure.
Collapse, you mean shrinking the...
Yes, shrinking of the hole. But you still see some reasonable ruby, you see reasonable amount of the material there. If it's like that, don't worry, just go ahead.
If it expands, it means that the sample will go out of the chamber. The problem is...
Yes.
What about if it shrink? I cannot see any problem. If it shrink, what can happen?
Measurement.
Measurement.
Problem is when you, for example, using X-ray.
We cannot take X-ray because it's very
Very small.
Very
area
small
and
size.
lots of gasket material will go into.
the only problem with
Most-
shrinking is this one.
Yes.
But expanding, the sample will go out.
Might
This is
go
the
out, yes.
problem with expanding. But shrinking is, I guess, better than expanding
Yes.
because
And then you're in shrinking. The main problem is that some moment, for example, you will lose your ruby. That is the
we
main
cannot
problem
get
because-
the spectrum of ruby.
Sometimes your ruby, for example, was sitting on the diamond, and then because of shrinking, your material just is covering the diamond, ruby, and you don't see the ruby anymore. That is the main issue with such thing.
And I guess as soon as it hits like the sides, it's not hydrostatic anymore.
They don't care about
They
hydrostatic.
do. Because in my case it was like that. It was
Hydrostatic, you mean the pressure should be uniform?
Uniaxial
in
pressure.
all the directions.
Because we are going to use powder, we are not worried about that. Why?
No, because your goal is not spectroscopy. In your case, your goal is synthesis of material, which is not not hydrostatic.
We don't need
Whatever.
uniform pressure.
Whatever, what you can do. You are not doing some precise experiment related to the property of the material itself. You are not doing fluorescence under pressure. You are not doing Raman under pressure. You are not characterizing that material which is there. Your goal is synthesis. Your goal is just to reach certain pressure when your material is stable. Even it's not hydrostatic, there is pressure. Okay, let's go with turning. Half turn. Half turn. Half turn. Half turn. Let's see what we get. 28 already. I believe we are very close to the number we need.
What is the number that we need?
We need around this number. It's already more, even 30. Maybe we made to tick already. Let's see. You can also observe sometimes your gasket during the indentation under microscope. Some people are able to see
The thickness under microscope.
yes. Sometimes people are able to see how deep it goes by knowing the geometry of the. Some people like to do it. When you know the geometry of your crystal, you know the angle. You see how deep it goes there. You see you might you might determine the thickness. Let's see what we get. We might need some more runs, more trials. So just it was one turn right now. Yes,
One turn.
one turn of the
And you did it by 2 half.
two halves. Yes. Mark is there. 134. I think it's good.
134.
For such size, I don't think you need more. If you think that it's not enough, you can put it back and make next squeezing.
1.5.
For example, make extra half. I'm not for this particular configuration. See, one turn make 130 thickness. We can try to do. I will show you how to do next. So since it is in case of the screw, it's much easier to fix it. So if you put it back, it's almost goes almost same position. See? Go same position. No, you don't have to worry about the orientation, whatever. Again, we are closing cell till we feel the first resistance.
We don't need to observe the place of the gasket again.
I believe it's.
What about in the other cell? In the other
side, it's more freedom.
For that one, we should observe after putting.
Yes. Putting, we must put. But here, I believe it's no other possibility than it's in that position. So first resistance, and then from this position, I'm making half turn again. I probably need to do more. Half turn.
Last time we did for 1 turn.
Yes, 1 turn, but again, the force we are creating was. I need little bit more, so I will make one extra quarter.
How many turn did you right now?
Yeah, this turn I did 1.25, but it's 1.25 on front of that previous. It means that the next turn must be little bit less than it's because it's already pre-indented.
Because I thought that you should do 1.25, but you did 1/2.
Yes, because actually you're right. I need to do a little bit. Let's see what we get. If there is any progress. If not, I will drill this one, like it is. But again, you have to establish more or less what parameters are good. I believe that for this cell, 100 micron would be ideal number. But if it's 130, it's not a big deal.
One question: why didn't you use this prepaid gasket?
Because I don't know what those gaskets are.
Uh-huh.
So I have more feeling with our material, and I don't want to use other.
But if they have lots of them, do you recommend me to use
115. Ideal.
115?
micron.
15.
115.
Okay. So we are not, for the second time, we should not do
Those say
exactly, we should not add to previous one.
no, because it's already pre-dented. So you need to go a little bit less because you relax it. It's strange mechanics. It's mechanics of the material which are already flowing. It's not just you must understand that this one it's sitting on spring, and this is not a spring. It's already deformed. Let's go. Now
And one question about a spring. When we use a spring for example, for sometimes, should we change them because they are not going to deform?
those, no, you will use them faster than you will damage them.
So we don't need to change them. We can use it for several years.
I believe so. Okay, this is 270.
270. We need
It's a half of the.
590.
Yes, we need 300, but we don't have 300. We will go with this one.
This one is 200 and...
70
Okay.
or around. Okay, where is the gasket? Here. Okay, now same thing. First I have to find the focus. Second I have to find my deformation indentation. Huge. It's almost whole field of view of the microscope.
Because the cullet is too
It's
big.
huge, yes. And then I have to bring out the from view of the field by liquid. I have already liquid. And I'm starting drilling. I'm making first the mark somewhere outside.
It's not similar to our drill machine, but how did you start with
Here
this
is
key?
the
Wait, there is the key.
so it's top up.
But the main key is over there. Okay,
Yes.
but it's not the.
Also all
technical.
regulation are on back. Your regulation are on top, the front panel.
You have access to changing the voltage of the.
Yes, here is the also. Actually, for the bigger drill, there is again in your machine there is table which telling what's the diameter of the bead.
Do you know our drill?
Yes. I was using such drill, so it means that drill is quite popular in different labs. That is expensive. Yours is much cheaper. So there's lots of labs you're using drills like you have. And there is table.
Anything special about that drill, or just I should go through the manual and I will find everything?
Practice. There is nothing, just practice. You have to learn how to turn, how to find the because the here my main issue is that calibration. In your machine, the main issue is good vision to see that gasket from one point of view, from other point of view, and then drill. If you're using like that 500 micron drill, cullet, and like 300 micron size bead, there will be no problem with pointing. Problem is if you have 100 micron cullet and 50 micron.
The problem that you are talking about is finding the center of the.
Because you look under microscope and you see your gasket from the side. You would see like that. You see oval of your gasket. You are trying to put your drill visually into middle of that gasket. And there are two knobs to.
I should focus the microscope in this way.
Yes.
Because I cannot bring it.
No.
In
You
this
look
way.
from the side.
From the side. This is the problem.
Okay, I did something already, I believe. Pump out.